guys?
Hi.
My name is Jeremy.
I'm Kevin,
And we're here to teach you about intermolecular forces.
Yeah! Intermolecular forces, also known as IMF, are the physical properties of a compound that are determined by the attractive forces between molecules.
So the first thing you should know about intermolecular forces are that they are electrostatic. That means that opposites attract. So let's go to the chemistry study room to show you guys more. Whoa. How'd you get here so fast? Weren't you just right next to me?
Hey baby, are you a charged atom? Because I got my eye on you.
The electrostatic interactions for neutral molecules, which are ones without form of charges, are classified into three basic types of intermolecular forces. The first are dipole-dipole. The second are hydrogen bonds. And last but not least are London dispersion forces. So why do we need to know this? And why is this important? Well, there are four physical characteristics that intermolecular forces help determine. The first is boiling point. Second is melting point. The third is viscosity. And last but not least is surface tension. While it is often difficult to use molecular structure alone to predict a precise melting point and boiling point of a compound, there are a few simple trends that will allow us to compare compounds in a relative way, such as which compound will boil at a higher temperature, which I will discuss later on. But first, let's get into the basics of each of the three interactions. So let's start with the first one, dipole-dipole interactions. It is between a positive and a negative charge. This happens between molecules with a permanent positive and negative. So for example, hydrochloric acid. This side is partial negative, this side is partial positive. With another one, HCl, and another one, this negative attracts to this positive, which creates an intermolecular force. And this negative attracts to this positive, which also creates another intermolecular force. This only happens when the molecule has a permanent dipole moment. So any nonpolar atoms or molecules cannot do this because they don't have a permanent partial positive and partial negative. Because of these intermolecular forces, this allows hydrochloric acid to be a liquid and combine to each other instead of just being a gas. So next we're going to talk about hydrogen bonds. They're similar to dipole-dipole interactions, but very strong, so they're taken up another level. So like I said, the next are hydrogen bonds. These are the strongest out of the three intermolecular forces. They're strong because hydrogen bonds work with a hydrogen, which is very low on the electronegativity scale, and it's usually bonded with either an oxygen, nitrogen, or fluorine. These are the only three atoms that hydrogen bonds with to form hydrogen bonds. Anything else would be a dipole-dipole if it's polar. Let's look at a water molecule. Oxygen is going to be a partial negative, while hydrogen is going to be a partial positive. So this creates a permanent dipole moment going this way, with negative on top and positive towards the hydrogens. Let's take a look at water, for example. Do you ever wonder why water doesn't just evaporate off of Earth? Well, it's because of hydrogen bonds. These hydrogen bonds aren't actual bonds, they're just hydrogens that interact with all the oxygens within each molecule. So these interactions allow the water molecules to form liquid, and because of these interactions, it raises the boiling point of these water molecules so that the the boiling point is 100 degrees Celsius. So let's take a look at ethanol and water, for example. Ethanol is also a polar molecule. It has hydrogen bonds, but it has a lower boiling point compared to water. Ethanol is 78 degrees Celsius, while water is 100 degrees Celsius. Water has a higher boiling point because there are more hydrogen bonds present compared to ethanol. Ethanol only has one hydrogen that could really bond compared to water, which has two. Lastly, let's talk about London dispersion forces. Do you ever wonder why propane, a nonpolar molecule, can be in a liquid form? Yeah, me neither. But I'm going to tell you anyways. So, propane is a nonpolar molecule. It's carbon, carbon, carbon connected to all hydrogens. The electronegativity is not great enough to create a permanent dipole-dipole moment. So, how does this stick together? London dispersion forces explains this. So if you remember from general chemistry, electrons are constantly moving around. But there are moments where the electrons sink and they start moving together. These together moments create a very brief moment where all the electrons go to one side and this part becomes a partial negative, and all the electrons are missing from this side, which becomes a partial positive. Same goes for this molecule. All the electrons swing here, which causes a partial negative, while the electrons are missing from here, which cause a partial positive. This brief moment allows for this molecule to connect to this molecule. And that allows the molecules to stick together and to cause it to form into a liquid. These London dispersion forces are going to be the weakest of the three basic intermolecular forces, or IMF. There are two things to take into consideration when you're talking about London dispersion forces. The first is the size of the molecule, the more surface area. Larger size means more electrons, right? So if more electrons move to one side, it's going to create a larger dipole-dipole moment, just briefly. But it still is a larger dipole-dipole moment compared to this one, which only has a few electrons compared to this. Also, how linear the molecule is determines the strength of the London dispersion force. If it's linear like this, all the molecules move here, so the dipole is concentrated, and you could draw a vector arrow. But compared to this molecule, which is more round, if they move one way, it doesn't create as much of a dipole-dipole moment. So it is slightly weaker and will thus cause the molecule to have a lower boiling point and melting point. Let's take a look at which molecules would have the highest boiling point. You could pause the video right now and take your time to go over it. Or we could wait a second. Good? Alright, let's do it. So, starting from the lowest boiling point, it would be this one. Next would be this one. Then it would be here. And then ethanol. And then water, as you may have guessed, would have the highest boiling point because of the hydrogen bonds compared to this molecule, which is nonpolar and only has London dispersion forces. So that concludes our video for intermolecular forces! Yeah! So, do you guys understand everything that I went over? No? That's okay. That's how I feel in all of my chemistry courses. So, study hard. You guys could watch the video again, ask your chemistry professor, ask some friends, and best of luck. You guys are gonna need it.
Hey babe, I heard you like big test tubes.